Hello class 8. So in the last video we did the introduction of light and we looked at something called refraction of light. I also gave you an introduction to something called refraction of light. And we looked at the two cases. Obviously we have two cases for refraction of light. The two cases are whenever a ray of light comes from a rarer medium to a denser medium. R denotes rarer medium and D denotes the denser medium. And the second case of course is the ray of light coming from a denser medium to a rarer medium. And we saw that whenever a ray of light comes from a rarer medium to a denser medium, the ray of light bends. Okay? And what happens is the ray of light bends towards the normal, as you can see, whenever the ray of light comes from a rarer medium to a denser medium. The ray of light was originally traveling in this direction. Okay, I hope it's fairly straight. So the ray of light actually was traveling in this direction, but what happens is the moment it entered another medium, okay, that is a denser medium in this case, the ray of light, it bends. Okay, it bends towards the normal whenever ray of light comes from rarer medium to denser medium. And whenever the ray of light comes from denser medium to rarer medium, we've seen that the ray of light bends away from the normal. It goes away from the normal. The original direction of the ray of light is somewhere over here. Okay, so this is the original direction of the ray of light. And this phenomenon of bending of light, whenever a ray of light travels from one medium to another, to be more precise, whenever a ray of light moves from one transparent medium to another is what is called refraction of light. The two media, it has to be transparent medium, obviously. Okay, otherwise the ray of light is not going to travel into the second medium, or simply it won't travel to the first medium itself. So both the media concerned, it has to be transparent medium, remember. So we say the phenomenon of bending of light when a ray of light travels from one transparent medium to another is what is called refraction of light. Now, like you've studied about laws of reflection when you studied reflection in class 7, here too in case of refraction we have two laws, okay, and similar to the first law of reflection, the first law of refraction also tells that the incident ray, which is AO, the refracted ray, which is OB, and the normal, which is NOM in both the cases, and the normal all lie on the same plane, PLA plane, don't forget, at the point of incidence. The point of incidence is O. So at point O, the ray of light, or rather the incident ray AO, is being incident. Alright, so point O is the point of incidence, remember. So at the point of incidence we see that the incident ray, the refracted ray and the normal, they are all lying on the plane of the board. In your case, if you draw this picture, which of course you have to, alright, the incident ray, the refracted ray and the normal, all of these three things will lie on the plane of the paper of your exercise book. Okay, so this law therefore is very much true. The incident ray, the refracted ray, not reflected ray, mind you, we are doing refraction. So incident ray, the refracted ray and the normal all lie on the same plane at the point of incidence. So this is your first law of refraction. You can pause the video and copy this. So I believe you've done that. Alright, so where do I write my second law? Where do I write? Should I erase the picture? Okay, let me erase this picture. Okay, let me keep the other one. Let me erase this picture. And let me erase the heading too. So the second law of refraction tells us, this is more of a mathematical statement, okay? It says the ratio, alright? So the ratio is a mathematical word, don't forget, and I hope you understand its meaning. The ratio of the This is SINE and it is read as sine, SINE, sine. Okay. I will tell you that you won't understand this right now. Okay, the ratio, but still you have to write this. The ratio of the sine of the angle of incidence, DENCE, the ratio of the sine of angle of incidence to the sine of the angle of refraction is a constant. Alright, furthermore it says, okay, constant, let me substitute the full stop by a comma, is a constant which is called the refractive index of the second medium, alright, with respect to, you can write W dot or T, okay, with respect to the first medium. Now, whenever I have to tell the second law of refraction, especially to class 8, I cannot help but say that you have to mark this this statement up. Because, like I already told you, this statement is more of a mathematical statement, and these words over here, sine of the angle of incidence, sine of the angle of refraction, these words over here are more of, they are truly mathematical terms, and you are only going to study about sine of an angle, whatever kind of an angle it be it angle of incidence, be it angle of refraction, or there could be other kinds of angles too. Okay, you study about sine, and there's something called cos, tan, cot, okay, so many other things. These are called trigonometrical ratios, and you will only study about that in class 10. Okay, so for now, therefore I'm saying class 8, even if I try to explain you this, it's going to be difficult for you. Alright, so it's better I do not try to explain you what these terms actually mean. Okay, you will also do refraction of light in class 10. Okay, now whoever will be your physics teacher in class 10, he or she will help you understand these terms after you reach class 10. For now, what I can only tell you is this sine, S-I-N-E, sine, sometimes is only simply written as S-I-N, but you don't read this as sin, you still read this as sine. Okay, so you have to understand this sine, whether you write S-I-N-E or S-I-N, basically usually it is written as S-I-N, but is read as sine. So sine of angle of incidence, or you can write angle I, divided by sine of angle of refraction. R is the angle of refraction, I is the angle of incidence. So it says ratio of this and this. So ratio means a fraction, division, so to say. So sine of angle of incidence divided by sine of angle of refraction, this statement says, is some constant, and that constant is denoted by, what do I say now, a U, so to say, with a trunk. Alright, U with a trunk. Now this is a Greek letter. This Greek letter is read as M-E-W, mu. It's not meow, alright, like a cat, okay, it's mu. This is read as mu. And this mu over here is denoting something called refractive index of the second medium with respect to the first. It's denoting something called refractive index. I'll talk about that. But refractive index is denoted by a U with a trunk, which is a Greek letter like I have told. So this is mu. Okay, you won't call this U with a trunk, remember. You will read this as mu. And mu, like I said, is representing refractive index, something called refractive index of the second medium with respect to the first, mind you. Okay, so to say, sine is like an operator. Sine is an operator which operates on angles. Okay, here also sine is an operator which operates on angles, and when they operate on an angle, what they give is they give some result, of course. The result is a number. Okay, so here in the numerator we are going to get a number. In the denominator also we are going to get some number depending on the value of I and R, of course. Okay, so that number divided by another number is going to give you a number, of course, which is a constant. And that constant, it is some number, remember, is called refractive index of the second medium with respect to the first. Alright? Now, what is this refractive index? Refractive index only tells you how dense or how rarer the second medium is with respect to the first. Alright, so refractive index is some number, is some value, so to say. So that value or that number gives you an idea about how dense or how rarer the second medium is with respect to the first. Understood? Alright, so this is about the laws of refraction, and this is the only thing that we are going to discuss in this video. Thank you, classmate.